Hello, hello. We are ready to go for skill 8. So if this isn't the skill you wanted, sorry, go back and find the one that you do want. But we're ready to talk about parallel lines. All right, we've been talking a lot about perpendicular lines so far, but we're going to spend a little bit of some time on parallel lines here. So in order to do this construction, we are going to use the angle bisector construction that you already know. And if you forgot what the angle bisector construction is, feel free to pause, take out your notes, or you already have your notes out, flip back and look at those, or I'm going to essentially go over it with you again here. Now again, like we've been saying over and over and over again, it is super important to remember to keep the same radius, all right, throughout this construction. So if you change your radius after you have it set, you are not going to get parallel lines. You're going to get non-parallel lines, lines that are going to cross. Okay. So looking at this example 1 here, it says construct a line parallel to the given segment, but it must pass through point C. So first, a little side note here, all right? Parallel means lines that never touch. So think about railroad tracks. Think about the yellow stripes down the middle of the road. Those lines go on forever, and they're never ever going to touch no matter how long they would go on for. So we want to draw a line that's going to look something like this. Now, you can't just use your compass and say, oh, I think it's going to be like that. No, wouldn't get you credit. All right, so here's how you will get your credit. We know our line has to pass through point C, and here's C. So the first thing I'm going to do is I'm going to take C, and I'm going to connect it back to my original line that was given to me. All right, and I'm gonna make it pass through I. If you extended your line, if your line's going up here, that's fine. There's nothing wrong with that. But I just had mine stop at C. All right. So here's where your angle bisector construction is going to come into play. So angle bisector construction says you put your compass on the vertex, which I did, and then you open it up to swing an arc. Well, I know mine has to pass through C, so I better align my compass up with C. All right. So once you have it set, go ahead and swing that arc. Okay. So that was always step 1 with your angle bisector construction. Step 2 is to draw in those baby arcs. And if you remember, you get one of the baby arcs by putting your compass up here at the top point of intersection, which for us is C. Let's do red. All right. And you get the other point by moving your compass to this other point of intersection, which would be down here. And again, I'm not changing my radius. If I do, I'm not going to get the parallel line that I want. Okay. So now don't get ahead of yourself here and go ahead and draw your line back. Don't do it, because you're going to bisect the angle. We don't want that. We want a parallel line. So what you should be able to do, if your construction was done right, connect C to where those baby arcs intersected, and you will have yourself a parallel line. If your line is not parallel or really, really close, your compass might have just slipped on one of the arcs or baby arcs there. So just test it a little bit out on this next one to see if you can get it precisely parallel as much as possible. All right. So again, if you're a little bit behind or didn't get something, pause, stop, rewind, go back. Here's example 2 though. Construct a line parallel to the given line passing through point P. So it's essentially the same directions we had up above. But if you notice here, in this example, we had a segment AB because it had endpoints. Here I have a line. So my first step last time was to connect P, which would have been C up there, back. So you can connect it back, but you can actually connect it back anywhere on this line that you want. All right, you could connect it back all the way to this arrow, but to change things up here and just prove to you that it doesn't matter, I'm going to connect it this way. And I'm not going to connect it to the arrow. I'm just going to go down a little bit here and connect it to this random point here. All right, if you do connect it to the arrow, that's fine. And again, if you extended your line farther, it doesn't matter. But you just got to connect P back to your line somehow to get an angle so we can do our construction. Okay? So after you connect, we put your compass on that vertex, wherever yours might be. And remember, you have to set your radius to be P. And what do you know? Mine's right on. So adjust yours. But remember, we have to measure it so it's that length. And I'm going to go ahead and swing that arc. Without changing your radius, I move my compass to point P, that first point of intersection. I draw myself a baby arc out here. I move my compass to the other point of intersection. Draw my baby arc out here. And last step, again, don't draw your bisector. but connect and draw your parallel lines. All right, it's always a good idea to go back and reread the question because since you're doing almost exactly the same steps, you want to make sure that you have the right final steps so you don't lose any points. All right, mine's a little bit off from parallel, but that's your construction there. All right, so we don't have the steps written out here, but if you wanted to write the steps out, please feel free. You have some space off to the side here. Any questions that you have that you're unsure of, or like using your notes, like how would I construct a parallel line? Maybe you jot that over here, and then here's your picture of how you'd go about it. All right. If you flip over to the next page, once you're all set with that, the last thing we're going to talk about are some of the angles that are formed with parallel lines. All right, so there's 4 types of angles. You might have heard of some of these before. And I'm just going to go through these different types with you because they do come back pretty frequently, especially in our next unit here. So the first one we have are alternate interior angles. They are already kind of labeled for you here in your picture if you look closely. That would be angle 3 and angle 6. Hence the name alternate, meaning opposites. They're on opposite sides of this line. And interior meaning that they're in between the inside of your line. They're not on the outside, but they're on the inside. So those are alternate interior. And there's actually another pair of alternate interior angles. If you guessed it, it is angles, or they are angles 4 and 5. All right, so I'm going to jot those down here. Angle 4 and angle 5. All right, so you have 2 pairs of alternate interior angles. And a little side note to jot down, they are congruent. All right, so meaning whatever angle 3 is, angle 6 is going to be the same measure. Whatever angle 4 is, angle 5 is going to be the same measure. All right. I'm going to go down here rather than around clockwise. Alternate exterior. Again, one set of these is already labeled for you. Angle 2 would be considered alternate exterior to angle 7. All right. Using our vocab again, alternate means they are on opposite sides of this line. 2 is on the right side of the line, 7 is on the left side of the line. Exterior meaning they are on the outsides of these 2 lines. They're not in between, but they're on the outside, the exterior portion of them. There's another pair. If you look closely, angles 1 and 8. All right, that's the one other pair of alternate exterior. There's not more than one pair that I just found. There's only the 2 that we colored in, 1 and 8. And just like alternate interior angles, these are also congruent. So if angle 1 was 100 degrees, angle 8 is going to be 100 degrees. They're going to match. Almost done. Corresponding. This one's a little bit different. How I like to explain corresponding angles, because if you look at the ones that were already given to you, angles 2 and angle 6. Corresponding angles are like twins. So if I picked up this set of 4 angles and were to drop them down here, 2 would be in the same exact spot that 6 was. All right. So there's actually more than 2 pairs of corresponding angles. So you might be saying, well, Miss Wesley, 1 would correspond with 5. And you're right, it would. But 3 would also correspond with 7, because it's kind of that bottom left spot. And likewise, 4 would correspond with 8. So you actually have 4 pairs of corresponding angles. It says just name 1 pair, so let's go with 3 and 7 because we haven't used those numbers yet. All right. And just like the 2 types of angles before, alternate interior, alternate exterior, and I said they're twins, these angles are also congruent. So again, if I give you an example, if angle 2 was 70 degrees, angle 6 is going to be 70 degrees. They're going to match, they're congruent, they're the same exact measure. The last types of angles that we have here, same side, interior or exterior. There's actually both, but they have the same characteristics. The ones that we have labeled here, angle 4, all right, and angle 6. All right. Notice I didn't color that one in, and I got a reason behind it. These would be considered same side because they're both on the same side of the line. They're both on the right side of our picture. These would be same side interior because they're in between these 2 lines. If we wanted a pair of same side exterior, that would be along the lines of angle 1 and angle 7. All right. Those would be same side exterior because, again, they're on the same side of the line. They're both on the left. and they're both on the outside. So we could jot those down. Angle 1 and angle 7, and these are actually your same side exterior. Right. But like the 3 previous ones, these pairs of angles are not congruent. All right, 4 is not going to be the same measure as 6. 1 is not going to be the same measure as 7, but rather they are supplementary. And if you're not sure what that word means, that means that they have to add to, I don't want to get cut off here, 180 degrees. All right. So if angle 4 was 100 degrees, that means angle 6 has to be 80 because together they have to add up to 180. So that was kind of a lot of information there at the end. You do have your parallel lines construction that we went over, and this is an important one to know. So look these over, keep your notes out, grab those practice packets, work through them, come see us with questions, and then get to taking that CFU whenever you're ready. See you next time.